Hello, so let us look at number 11 and on up to number 20 in this part. So first term in the sequence is 2005. Each succeeding term is the sum of the cubes of the digits of the previous term. So, for example, the first one is 2005. How about the second term? Then it will be cube of 2, which will be 8, plus cube of 5 is 125. Then this becomes 133. Now, then how about the next number? Cube of 1 is simply 1. Cube of 3 becomes 27, plus 27 once again. Then it becomes 55. Now, the next one, fourth one would have been cube of 5 becomes 125 and 125, which is equal to 250. But wait a minute. Did you realize that here 250 or 2005, both of them has only 1, 2 and then 1, 5? So the next one would have been equal to 133 and then 155. So in other words, we have cycles of 3 numbers. Now, so when you divide 2005 by 3, we realize that that's equal to same thing as 1 modulo 3. In other words, when I divide 2005 by 3, then I will get 1 as a remainder. So therefore, our answer will be same thing as these two. In other words, 250 will be the value for 2005 term. Alright, let us look at number 12. The 12 fair die are rolled. What is the probability that the product of the numbers on the top face is prime? How can we have the product to be a prime number? That means there's only one prime, and then the rest of them should be 1. That's basically what has to happen. Now, what is the probability of getting a prime number? Since there are 3 primes, 2, 3, 5. So therefore, getting a prime number is simply equal to 1/2. But all the other stuff has to be 1, so it will be simply 1/6. But how many ones should we get? Out of 12 fair dice, we need 11 of those. Now, the next one is this. Then when you look through this one, how many different ways can we have one prime number out of 12 places? Prime number can be in the first place, or second, or third. So that in total, we have 12 ways of doing it. So once you cancel these two things out, this becomes 6. And 6 can cancel out one of the 1/6. So now it becomes 10th power. So 1/6 to the 10th power, which is choice E becomes our answer. How many numbers between 1 and 2005 are integer multiple of 3 or 4? Okay, then in this case we can use the Venn diagram, I guess. So here we can be multiples of 3. Here multiples of 4. Because some are multiples of 3 and 4 at the same time, but not multiples of 12. That's basically here. Then how are we going to do it? First, we can find the multiples of 3, which we can do by 2005 divided by 3, and then get the greatest integer function. Basically truncating the all the decimal point. So then 2005 divided by 3 becomes here 20 divided by 3 becomes 6. And leaving another 2 becomes 6. And then out of 25, 3 goes into 8 times. So 6, 6, 8. And then a remainder of, yes, 1/3. But that cancels out. Simply 668 is basically how many we have. Then that takes care of this part of the circle and that part of the circle. How about 4? So we're going to do 2005 divided by 4. Then this one will give us 501. Now, so then that takes care of these two. But wait a minute. we have counted multiples of 12 two times, as you can see in this section, because that was part of 3 and part of 4. But we don't want any part 12s, so basically what we can do is we can 2005 divided by 12. Or we can do it this way, or we can just divide this one by 3, or divide this one by 4. Either way will be okay. Then you will see that this would have been equal to 1, 1, 6, and then 7. But we have to take them out 2 times. So our answer will be 668 plus 501, but minus 2 times of 167. That becomes our final answer. Here, then it becomes 1169 minus 334. That becomes 2 times of 167. Then once you subtract them, then it becomes 5, 3, and it becomes 8. 835, which is choice C. Number 14. In an equilateral triangle has side length of 2. So all sides are 2, that means CD is also equal to 2. But since M is only midpoint, that means whatever the height we would have had, the height of them also would have been half of the entire height. Since this is 2, then this is 1, that makes the height would have been radical 3 for the big equilateral triangle. But half of them, so height in the small triangle would have been radical 3 over 2, half of that. So therefore, area of that triangle CDM would have been equal to 1/2 base, which is equal to 2, times height, which is radical 3 over 2. Then these two cancels out. We have radical 3 over 2, which is choice C becomes our answer. Number 15, so let's look at this one together. So here we have 2 bills are drawn at random without replacement. What is the probability that their sum is $20 or more? So then how many ways can we pick up 2 bills out of 8 bills? It will be 8C2, which will be in fact equal to 28. Then how many ways can we pick out 20 bills? So number of 20s. And number of ways. How many ways can we pick 2 20s? In fact, it would have been only one way, because how about pick only 120s? Then I got to pick 120 and then 6 of those. So therefore 1 times 6, but at the same time I could pick one of these 6 first and then I get one of the 2 20s. So we just have to multiply that by 2. How about 0 20s? Then the only way that's possible is I have to pick 2 10s. There's only one way of doing that. So when you combine them together, we get 14 out of 28, which is choice D, 1/2. Number 16, the quadratic function, a quadratic equation that we have here, has the roots that are twice those of this one. So in other words, if the roots of this equation is R1 and R2, the roots of the second equation, this one, would have been equal to 2R1 and then 2R2. That's basically what's going to be happening. Now, none of M and P is 0. What is the value of N over P? But notice that M is common in both cases. So let's try to look at it. What is M? M here is equal to R1 times R2. Because product of the root is equal to M, while R1 plus R2 is equal to P. Now, how about here? From here, when you add them up, so we end up getting 2 times of R1 plus R2 by factoring, sum of the roots will be negative m. Actually, this one should be negative p also. Negative b over a. And then product of the roots, in other words, 4 r1 times r2 is equal to n. Now, we notice that this one is common. And then these are also common. That means if I were to place this one over here, then we get to realize that 2 times negative p must be equal to negative m by substituting r plus 1 with negative p. That tells us that p is equal to m over 2. Now, on the other hand, how about here? When you plug in m for r1 times r2 in this location, then 4m must be equal to n. So using these two equations, we can plug them into here. Then n will be equal to n over p must be equal to 4m over m over 2. So obviously m's cancels out. This becomes 8. Choice D becomes our answer. Number 17. So 4 to the a power, 5 to the b power. But these numbers keep on repeating itself. Alright, and what is the a times b times c times d? Let us try to go for the substitution here. Because 5 is common in both cases, and 5 can be expressed as 4 to the a power. So when I combine these two, I can say, instead of 5, I can put 4 to the a power. To the b power, because from here, it must be equal to 6. In other words, this one tells us that 4 to the ab must be equal to 6. Similarly, in place of 6, I can put 4 to the ab power. Then we get 4 to the ab power to the c power, because that's what 6 was, is equal to 7. That means 4 to the ABC must be equal to 7. Next one, but 7 is in fact D here, so we can use the substitution here one more time. Then we get 4 to the A, B, C, D must be equal to 8. But both of them shares 2 as their basis. So here what we end up getting is 2 square A, B, C, D must be equal to 2 to the third power. In other words, A, B, C, D times 2 must be equal to 3. So when we try to get A, B, C, D all alone, we just have to divide by 2. And A, B, C, D becomes 3 over 2, which is choice B. Number 18. Of all David's telephone number have the form of 555, and then we have A, B, C, D, E, F, G, where these alphabets are distinct digits, meaning none of them are same, and in increasing order. And none of these are either 0 or 1. Now then, if you think about it, how many numbers are possible then? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have total 10 numbers. But out of that, these two are not possible. That means how many numbers are left? We have 8 numbers here. 4 place of 7 places. That means what's going to be happening is any one of these numbers cannot actually, one of these numbers cannot go into this list. It can be this one or this one or this one. In fact, total we have 8 possible choices of one number that cannot be part of the telephone number. So therefore our answer would be 8. That's how many different phone numbers which David I guess could have. Alright, number 19. On a certain math exam, 10% of the students got 70 points, and then 25% got 80 points, and then so forth and so on. What is the difference between mean and median? So, median would have been the 50th percentile, so 50th percentile would have been 10, 25, therefore it becomes total 35. 35 plus 20 becomes 55. So 50th percentile should be in this section here, isn't it? So median must be equal to 85. How about mean? Mean is the average. So if I were to rewrite all these things, then it would have been something like this. 10% of that, then basically similar to calculating the expected value. So here, 10% of 70 plus 25% of 80 points plus 20% of 85 and 15% of 90, and then the rest got 95 points. That means this one is total 35, 55, and 70. That means this one is the 30%. We'll end up getting 95 points. Let's see if this one is relatively accurate or not. So here 10, 35, 55, and then 70. Okay. Now, to find the mean, all we have to do is just get these values in together. So here we get cancels out. So we end up getting cancels out becomes 7. Here, these two cancels out becomes 4. Cancels out becomes 20. So we end up getting 20 here from the second value. Here this becomes 5. So 5 cancels out with 85, becomes 17. Here I can cancel them out by 5, then I get 3, and then here we get 20. And cancels out here. Then we end up getting 27 over 2. Here 0, 0 cancels out. And then if I were to divide by 5, then I get 2 left here. If I were to divide this one by 5, I get 19. So 3 times 19 is 57 divided by 2. 57 over 2. So if I were to add up these numbers, 1, 2, 3, 4, 5, then I'll end up getting the mean of the values. So here we get 27, and then 44. And here it becomes 84 divided by 2. Becomes 42. Now, then when you add them up, it becomes 86. So median was 85 and the mean is 86, therefore difference becomes 1. Let us look at number 20. What is the average of the all 5-digit number can be formed using these 5 digits exactly once? Okay. That means since these 5 numbers has to make up a number, in other words, we would have had 5 choices. The second one will be 4 choices, and 3 choices, and 2 choices, and a 1. So we'll end up getting total 120 choices. Now, but the thing is this. What if my first number were to be 1? How many choices do I have on the second? And then, if I have freedom to pick second, third, fourth, and fifth, that means basically I'll be having 4 times 3 times 2 times 1. In other words, 24. For example, basically what this one tells us is that 1 will come out 24 times, 3 will come out 24 times, 5 will come out 24 times in the very first digit, and then 7 and 8. In fact, this pattern will repeat itself every single places. You will realize that that particular number will come out 24 times. Now, since they're equally distributed and then they're equally likely to come out, then basically what we have to do is, instead of finding the average of those 24 numbers, 120 numbers, we're just gonna assume that 1 will come to the first digit 24 times, but equally as likely as 3, and then 5 and 7 and 8. Same thing for second digit. So what we're gonna be doing is we're gonna simply get the average of each digit and add them up. So what is the average of these 5 numbers? 1, 3, 5, 7, 8. When you add them up, we get 24. So therefore average of each digit would have been 4.8. 24 divided by 5. Now, that means the 5-digit number, so we have, this one would have been 4.8. Notice how I'm going to write it 4.8. Since it's not quite a whole number, 8 has to go to the next digit. But second digit will be exactly the same thing as the first digit, so average would have been, the average of the digits would have been 4.8. And then 4.8 and 4.8. And the fifth digit will be also what? 4.8. So when you add them up, it becomes 2. And 1 goes up, therefore 3, 3, 3, and then it becomes 5. So our answer is 5333, 2.8, which is choice C. Alright, and then we'll stop here, and I'll see you later. Bye-bye.